Hello, everybody. So we are going on to page 35, our second page of notes for this week, and we're going to talk about the volume of cones, which is nice because it's going to be super similar to what you've already been working on. So, volume of cones, page 35, works the same way as volume of pyramids. Same exact way, 1/3 big B times h, or volume is equal to big B times h divided by 3. Again, big B being area of the base. So in this case, you're going to have to find the area of a circle. Again, be mindful with pyramids and cones, you can have height or slant height. You have to plug in regular height for these. Slant height is used for surface area, but we're not talking about surface area, we're talking about volume. So, my first example says find the volume of a cone with a diameter of 20 millimeters and a height of 6 millimeters. Leave it as the exact answer. So let's go over here to example 1 where we can work on that. Okay, so I can actually draw cones, guys. This is one that I can do. So a cone is going to look something like this. We're going to find my pen. There it is. Come down here, draw. There we go. There's my cone. So I know that it has a diameter across of 20 millimeters. So that tells me that if it goes diameter 20 millimeters, I don't really want the diameter, right? We know that for our formulas, we're probably going to want the radius. So I'm going to put the radius there, 10. And that tells me it has a height of 6 millimeters. So the height is going to come straight down to the center, and I get 6. This is nice for this problem because it doesn't give me the slant height, it gives me the actual height. So I don't have to do an extra Pythagorean theorem step because they gave me the height up front. So we're going to start by finding area of the base. In this case, the base is a circle, so we're going to use area equals pi r squared. I'm going to plug in my radius there, so pi times 10 squared, and I get area equals 100 pi. And because it said to leave it exact, I'm going to leave it just like that and not go any further. Now I can go in and just plug into the formula. Volume equals big B times h divided by 3. Anytime a shape comes to a single point, you know you're going to divide by 3 at the end. That's a good way to remember it. If they don't come to a point, you just do big B times h. If they come to a point, you do big B times h and divide it by 3. So we have volume equals 100 pi times the height of 6 divided by 3. Well, 6 times 100 pi gives me 600 pi, and 600 pi divided by 3 gives me 200 pi. So I'm going to have 200 pi millimeters cubed, since our volume will be cubed again. And that's my final answer for that one. Super, super easy. Start off with a nice, simple one to not overcomplicate it. Okay, there is the work for that so you can see it. Now, example 2 is a great question. Example 2 would be something you would expect to see on the FSA that you don't have to take. But we're going to look at it anyways because it's a good question. It says, if I have two cones, and I'm told the two cones have the exact same volume, then find the radius of the second one, which really I meant to actually make it the radius of the first one. That's where the radius is missing, right? I want to find the radius of that first cone. So I know that ultimately these two cones have the same exact volume. They hold the same weight or the same mass inside of them. So that's kind of tough to figure out, right? Like, how does this affect it? Is the radius here is 10, but this is 5. So does that mean we could just multiply this? See, it doesn't just work simple. We have to think about the equation as a whole and try plugging in the parts we know. What I know is the volume over here is equal to the volume over here. And I know the volume is big B times h. And even further, I know that big B in both of them is a circle, so it's going to be pi r squared times h is equal to pi r squared times h. What this helps me do is address the constants in the problem, right? If you were thinking about this, well, if I multiply both sides by pi, that doesn't really matter. The pi's cancel each other out. They do have different radiuses, though, so I'm not going to get rid of the radiuses. Oh, sorry, I messed this up. This is divided by 3, right? Divided by 3, which also doesn't matter, right? Because if you're dividing both sides by 3, 3 is a constant, it doesn't matter. The only things that are variables here are r and h. R squared times h on the left cone has to equal r squared times h on the right cone. And that's what we need. Once we cancel those pieces out, the 3 and the pi, we can focus on the parts that matter. Over here, the height is 20. And I don't know the radius. So I'm going to have r squared times 20 on the left. For the right cone, I have r squared times h, so I'm going to have 10 squared times the height of 5. So this is what I end up with. 20r squared when I work that out. And over here, 10 squared is 100. 100 times 5 is 500. So I end up with 20r squared equals 500. I can then divide both sides by 20. And I'm going to get r squared equals, that's going to be 25. Square root, r equals 5. So now I know the radius here has to be 5. I didn't use units, so we'll just put units. 5 units. And that would be the solution there. So that was a nice quick video. Hopefully that gets you going in the right direction on that. If you need help, I know IXL can throw some tougher ones at you, so definitely don't hesitate to come talk to me if you need some help. There it is, worked out in nice, neat handwriting. Best of luck. Let me know if you have any questions this week. Bye.